going on YouTube? So we did the car hacking video last week, and so I was just shopping at Aldi's with my girlfriend, and I saw these Christmas remote outlets, and I got the idea, hey, if we can unlock a car, we can also do some home automation stuff with this. So basically, as far as I've gotten is kind of just picking this up and unpacking it. And normally I do the whole project, and I'll go back and do the steps that I did on YouTube. But this time I'm just going to bring you guys with me in my thought journey, and kind of see my thought process on how this is going to work. So really, for this project, you're going to need some type of remote outlets. I'm using this Merry Christmas. It's a pretty generic indoor outlet system. It's got three. It looks like it's got a channel 1, a channel 2, and a channel 3. On the remote, it looks like we have a channel 1 off, channel 2 off, channel 3 off, and on. So there's going to be 2 different codes, so that makes it quite easy. And I've already looked on the back. I don't know if you guys can see this, but there is a FCC ID here that we can use to search online to see what frequency this actually operates in. And of course, we're going to have the Raspberry Pi, and just like the last video, we're going to be using it to transmit our codes. And I've just attached the antenna just the same onto GPIO pin 4, just as we did in the other video, our pin 7, and I've stuffed cotton down in it, and this is going to act as our antenna. So the first step that we're going to do is just determine the frequency that this thing is going to operate on, and we'll go from there. So as always with these things, the first thing that we're going to start on is determining the frequency that our remote device is going to operate on, because we want to see where the commands are being sent. Our end goal here, for me honestly, just for this little project, is to be able to plug one of these outlets up to the coffee pot, and then have a Raspberry Pi transmit an on and off frequency every morning for it to turn on and then turn off automatically in case I forget. And this is going to be probably on weekdays when I work. So I'm just going to go ahead and start off by going to the fccid.io website to go ahead and put in the FCC ID that I see on this. Now normally they'll just be right out on these types of communication devices, but sometimes you have to open battery doors and this and that to see them. But lawfully, if they transmit a radio frequency, they're required to have one. So in this case, it's going to be a PAGTR-031. So here we have our device here, and it looks like it operates in 433.92. There's only one frequency there, so that's pretty easy. So I'm going to go ahead and copy that and pull up a notepad here. And we'll just go ahead and paste it in. And not all these listed here are going to be exact, so that's why we have to check the frequency first. So you'll want to go ahead and plug in your RTLSDR dongle or any type of software-defined radio so we can see the radio spectrum. And I'm using SDR Sharp because I had the RTLSDR. So we're going to go ahead and pull this up. And it's a 433.92. So we're going to go ahead and play. And I'm going to go ahead to go to that 433.92 spectrum. And it looks like there's already a signal sent there. So I'm guessing somebody else, maybe in this department, has one of these, or maybe they're so frequent that a lot of people have them, but there are some signals being sent on this frequency. So I'm going to go ahead and hit my on and see where it's at there for channel 1, and I'm going to go ahead and line up with it. Let's see. It looks like we're going to have to tune it just a tad bit. So this is 433.975, and it looks like it's just before what we need. So we're going to do 433.975, or let's do 980. 433.980. See if that doesn't line up. We'll go ahead and hit the on button. That's right on it. So that's the actual on frequency for channel 1. So I'm going to go ahead and write that down on the notepad. So chan 1 equals 433.980. I'm going to hit the off and see if it's on the same frequency. It's on the same frequency, so that makes it super easy. And I'm just going to try channel 2. Channel 2 is on the same one. Channel 3. Okay, so I just went through all 4 channels on and off. They're all in the same frequency, so this right here is what we want. 433.980. So that is the frequency that everything is actually happening on. And we're in the narrow FM spectrum. This is probably in like an AM tone, but we're gonna what we're gonna do now is we're gonna go ahead and plug up the Raspberry Pi with the antenna. We're gonna plug in the RTLSDR, and we're just gonna give it a quick shot and just record the signal on that frequency and replay it and see if we don't just go ahead and like it may work that easy. If that's the case, what we'll have to do from there to do our like autonomous coffee pot is just have it run a script to play the on and off files at scheduled times throughout the week, which would be super easy. So we'll go ahead and move on to SSH into the Raspberry Pi now. Alright, so we're back, and we're getting ready to SSH into the Raspberry Pi. I already have the necessary programs to record and replay frequencies on my Raspberry Pi from the car hacking video. So if you guys want to see how to install that, you can either go to that video, but I'm also going to go ahead and post the commands on the screen here for getting it downloaded, installed, and compiled onto the Pi. If you're watching this, I would hope you have a basic understanding of how to run these scripts, because if not, you're going to have to go back and do some of that before you can really understand what's happening here. But I'm going to go ahead and log into the Raspberry Pi. If we can remember the password, that is. There we go. So I'm going to go ahead and ls, because I don't remember exactly what we had going on here on the Pi. And let's see. So our last, this is the command for the car hacking video that we had. This was the command that we issued to, to play the IQ file. And I just have to go up and find the command that records it. Alright, so we had to go through a bunch of trial and error here because I had some of the parameters incorrect, but that's part of kind of taking you guys with me through this. So let's start all over. Let's just go ahead and clear the screen, and here we have our frequency. This is going to be our send frequency right here, and this is going our recording frequency, and this is going to be our send. So I'm going to go ahead and issue this the recording frequency, and we're going to rename that file to let's call it turnonlight. Okay, so we're going to copy this, and we're going to put that into our Raspberry Pi's SSH terminal inside the Raspberry Pi directory, or the Raspberry TX directory. I'm going to hit this, and I'm going to hit the ones a few times, okay? And then I'm going to hit Control-C, and that's going to stop the recording. Now normally it would turn on the light. The light's already turned on, of course, so I'm going to go ahead and turn it off. And what should have happened there is we've recorded ourselves turning on the light and put it onto the IQ file. So now we can just take the same name for the file, and we'll call it turnonlight again, because it's the same file that we're sending out. And we're going to copy this file, but we're going to go ahead and put sudo in front of it, since this command has to be run as a super user. And we're going to copy that, right click, copy. We're going to paste that in. And what's going to happen when we issue this command is it's going to take that file we just recorded when we were hitting the on button, that turnonlight.iq, and it's going to retransmit it through the Raspberry Pi and turn on this light with their. So instead of using a remote, the computer's going to do it. So we're going to hit enter, and there we go. The light turns on. So what do we have now? We have a file called turnonlight that will turn on the light. Now we need a turn off light. So this is super simple because it's all on the same frequency. We're going to take that turn on light, we're going to issue a turn off light. We're going to name both of them into commands to test them. And now we're going to copy this in, and it's going to issue the same command, it's going to do the same recording, but now it's going to turn it off the light. So we're going to go ahead and issue that command. Just as we did turn on light, we're going to hit turn off light a few times on the remote. Hit Control C. And there we have it. So now we have our IQ file, and now when we issue the turn off light send file, to send that file, it should turn off the light. So let's go ahead and turn it back on, and we can actually do that with our turn on light. Light's on, it sends the command, and now we're going to reissue that send file, but this time we're going to send our turn off light. Boom. So what have we done so far? We've created a command that will turn on that outlet and turn off that outlet from our Raspberry Pi. So we've done the hard part. And this should work pretty much anywhere within your house. It has a transmit distance of quite a bit. So this is super cool. There's so many applications that we can do here, because now programmatically we can have a script enabled specific times of the day to control different things in our house from the Raspberry Pi, which, as you all know, can be plugged in 24/7 because it requires very little electricity. So that's some really cool stuff. So now it's kind of time to get into learning how to automate this system and do it from a script. And this is something I've never done before. So I'm going to go ahead and prepare and find a way to do this, and then I'm going to get back to the video. We're going to wire it up to the coffee pot and see how this can be useful. Alright, so I found all the solutions that we're going to need to our issues. And this is a two-step process. Sorry, I got something in my teeth. So the first thing that we're going to need to do is create a command that can be issued universally on the Raspberry Pi operating system that will still run those commands, or run those IQ files. The next thing we're going to do is schedule that file to be ran at certain intervals. So I have some of the commands posted up on the screen here, and the first thing that we're going to do is go ahead and create two scripts, a turn on and turn off script that can be just ran, and it will automatically issue the command for the light. So we're going to do sudo nano turn on 1.sh, and that's going to open up a new nano file. And I have the command here that's going to be posted in. It's the same command that we were using to send that turn on command, but it's been adjusted here so that now there's a directory path Okay, anyways, I had that command all wrong in the notepad, and that really just slipped me up. So basically, the first command that we're going to go ahead and eliminate some of these. I don't know why there's so many here. That's kind of odd. So we have a turn on light and a turn off light command. So we're going to take the turn on light, obviously, because we're into the SH, and I think I accidentally copied an extra space in there, so I'm going to backspace. And this command is the exact same as the command that we just issued to send the turn the light on, but we've modified it so that there is a included directory now so that if something is called from anywhere in the operating system, it'll automatically know to run that file from the Raspberry Pi TX directory. So once that's done, we're going to Control X. It's going to ask when to save, and then we're going to hit Control or Shift Y and Enter, and then we're going to make it executable by running chmod on turnonlight.sh. Now we're going to do the same thing with our turn off command. So we're going to do sudo nano turn off 1.sh. This time we're just going to paste that turn off light command in there. And then we're going to hit Control X, Shift Y, Enter, and we're going to chmod that one. And now, whenever we issue those simple sh files, they should just turn on and off the light just as the whole command. So we'll do, just to test it, /turn off 1.sh. Light turns off. And now we'll do /turn on 1.sh. Light turns on. So we now have two shell scripts in Linux that will automatically just turn on and off these lines from the Raspberry Pi. So now we just have to schedule that, because what we're going to do is hook that into the coffee maker and have it turn on every day at 7 a.m. and then turn off at, say, 9 o'clock-ish whenever I go to work, to make sure, you know, I don't forget to turn it off, or if I do, the Raspberry Pi will take care of that for us. So the easiest way to schedule tasks in Linux is going to be, and I think it ships with the Raspberry Pi, it's called cron. So you want to issue cron tab -e. And the first time you issue this command, it's actually going to ask what editor you're going to use. If you're a newbie, I really suggest Nano. I still use Nano. It does everything I need it to do, and it's not very complicated. So I already had the commands here, because I recorded the video without audio like an idiot. But the way this is laid out is, it's pretty much each line you put is going to be a scheduled task. So it's going to be the minute, the hour, the day of the month, minute, what is that one? Weekday, day of week command. Either way, we're just using the minute and hour. So minutes, we're going to do 0. The hour, we're going to do 7. And for the ones we don't use, we're going to put an asterisk. Asterisk, asterisk, asterisk. Because we're not going to do it on the day. We're going to do it as every time there's a 7th hour. And it's written in 24-hour time format. So if you're doing 7 p.m., it would actually be 19. So we're doing it at 7 a.m., so we're going to do 7. And the command that's going to be issued is going to be those that turn on file. So we're going to do a tilde, so we create a reference to the directory /turn on.sh. Oh, turn on 1.sh. And after that, we're going to go down and create one to turn off at 9 a.m. So we're going to do 0, 9, asterisk, 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 tilde, /turn off 1.sh. So now, all we have to do is Control X, Shift Y, Enter, and we have created a task that will automatically run to turn on and off that outlet, no matter what it's connected to, from the Raspberry Pi at 7 a.m. and 9 a.m. Now, applications for this are amazing. I mean, you have a lot of power between shell scripts and Linux and what you can do with it and to automate certain tasks at what time. So for $7.50 for the outlets that we just paid for, 3 or 4 of them, I forget how many. We don't need the remote anymore because we got the commands recorded. We should probably record all 4 channels, of course. But point is, now we can schedule tasks to have things turning on and off wherever it be throughout the house. And it's kind of like having those really expensive smart outlets that you can control your phone, but now we actually have more control over it because we can write scripts to execute it whenever we want. And in this case, I'm going to take this outlet that's on the light here, I'm going to plug it into the coffee pot, and every day it's going to make me a coffee at 7 a.m. and it's going to turn itself off at 9 a.m. because I don't have one of those fancy smart coffee pots either. So that's some pretty cool stuff. There's a lot of things you can think of to do with this, I'm sure. So if you guys like this little project, you know, and it's kind of weird going along with me as I'm learning because I wasn't exactly on top of everything. But it was interesting, nevertheless, to me. So if you guys like this video, make sure to subscribe, rate, and comment.